Have you ever played pool? Even if you can't cause a trick shot where balls seem to leap over others, pool tables are great places to see the laws of motion in practice. Unless your friend bumps the table, the balls all stay put until the slightest force acts upon them, just like Newton's first law of motion states. Meanwhile, hitting a ball harder causes it to move faster, proving Newton's second law. But what about his third law? Simply put, Newton's third law of motion makes pool possible. It states that for every action there is an equal and opposite reaction. In other words, if not for Newton's third law, the balls simply would not move across the table, much less bank off the walls for a shot that impresses your buddies. Think about anything you do, and there's a reaction to it. However, this isn't as simple as turning in your homework and getting an A. I'm talking complete science here. Let's say that your friend knocked in a great shot, effectively meaning that you lose the game. Out of sheer frustration, you punch the wall. Sure, if you were really mad and really strong, you might very well punch a hole through the wall. However, chances are that your hand is not exactly pristine after the punch. The wall exerted a force equal and opposite to what you exerted on the wall. In fact, it came off at exactly the same angle and everything. So what would happen if the wall did not exert such a force on your hand? In that case, your hand would flow effortlessly through the wall and into the restaurant booth on the other side. However, if that were the case, you'd have much bigger problems. Even breathing would be impossible without Newton's third law. Take a deep breath. While it may feel like there's nothing in the air, there is still a definite mass to all the oxygen, nitrogen, and carbon dioxide molecules in the air we breathe. Now exhale. Your diaphragm pushes all the air out of your lungs. The diaphragm acts on the air, and the air acts on the diaphragm. However, the contracting space in your lungs means that all of that air is forced out. Had your throat not been open to allow you to exhale, the pressure in your lungs would build. That's a pretty hard example to get, so let's try something with much more visible forces. Let's say that you were playing paintball, probably in an effort to get back at the friend who bested you in pool. You see him trying to sneak out from behind a barrel, and you let loose a whole spray of paintballs. However, your paintball gun pushes back against your shoulder as you do. The paintball leaves the gun with a force, but the equal and opposite part of the force ends up pressing back against your shoulder. Still, every time your body touches the ground, or something touches the ground, there is an equal and opposite reaction occurring. Gravity is to thank for making sure that you don't float off into space, but it is the normal force that is to thank for making sure that gravity doesn't suck you to the center of the earth. The normal force is the term given to the contact force that acts perpendicular to the surface. Remember your broken hand from punching that wall? That was an example of a contact force, if only instantaneously. This is why objects placed on a ramp are capable of sliding. Due to it being on a slope, gravity can overpower the pushback of the normal force. In this lesson, we looked at the real-life ramifications of Newton's third law of motion. Newton's third law states that for every action there is an equal and opposite reaction. We used the example of pool balls on a billiards table to show how forces can be transferred from one object to another. From there, we used the examples of breathing and shooting a paintball gun to demonstrate the equal and opposite parts of the reaction. With breathing, if there was no reaction, air would simply stay in the lungs, while the paintball gun kicking back is the equal and opposite force of the paintball being fired. Finally, we looked at the normal force, which acts as a force against gravity. However, it's not always equal and opposite, as it is perpendicular to the surface. As a result, items on a slope can fall down due to gravity acting upon them.